Imagine a star so massive and bright that it can be easily spotted in the night sky with the aid of telescopes, its fiery red glow a constant feature in one of the most famous constellations. Now imagine this star undergoing a strange and unprecedented transformation, releasing an enormous cloud of material into space and dimming dramatically, triggering widespread speculation among scientists and stargazers alike. This is the story of Betelgeuse, a red supergiant that has recently experienced a remarkable surface mass ejection, SME, shedding light quite literally on some of the most mysterious processes involved in stellar evolution. Betelgeuse, located in the constellation Orion, is one of the largest stars visible to the naked eye, as well as one of the brightest and most well-known. Its reddish hue is a telltale sign of its status as a red supergiant, a star that has swelled in size after burning through much of its nuclear fuel. Betelgeuse's name, derived from the Arabic term for the hand of Orion, refers to its position as the bright star marking the hunter's shoulder in the night sky. One of the most striking features of Betelgeuse is its sheer size. With a radius approximately 764 times that of the Sun, this celestial titan would engulf Earth and stretch beyond the orbit of Jupiter if it were placed at the center of our solar system. Yet despite its enormous dimensions, Betelgeuse lies relatively close to Earth in cosmic terms, between 430 and 724 light-years away, making it a prime candidate for study. Astronomers have long been fascinated by Betelgeuse, not only because of its size and brightness, but also because of what it represents: a star nearing the end of its life cycle. As a red supergiant, Betelgeuse is in the final stages of stellar evolution, having exhausted the hydrogen that once fueled its core. In its remaining lifetime, which could range from a few thousand to 100,000 years, Betelgeuse is expected to explode as a supernova, a spectacular event that will briefly outshine the entire galaxy. Betelgeuse has always exhibited some variability in its brightness, but in late 2019, it began to behave in ways that left astronomers puzzled. The star started to dim dramatically, losing about 2.5 times its normal brightness. By February 2020, Betelgeuse had faded so much that it was no longer the familiar bright red star that had anchored Orion's shoulder for millennia. The sudden and severe dimming sparked intense interest from the scientific community, as well as a wave of public curiosity. Given that Betelgeuse is known to be in the late stages of its life cycle, some astronomers speculated that this dimming might be the precursor to a long-anticipated supernova. Such an explosion would be a once-in-a-lifetime event for astronomers and sky watchers. A Betelgeuse supernova would briefly turn night into day, outshining even the full moon for weeks or months. The remnants of the explosion would form a new nebula, and the star's light would be visible during daylight for a prolonged period, offering a front-row seat to a rare cosmic event. However, as exciting as this possibility was, further observations soon revealed that Betelgeuse's dimming was likely due to a different phenomenon altogether. By mid-2020, the star had returned to nearly its original brightness, suggesting that something other than an impending supernova had caused the unusual dimming. The explanation that emerged was equally astonishing, though far less apocalyptic. Betelgeuse had undergone an enormous surface mass ejection, SME, expelling a vast amount of material from its outer layers. To understand what makes Betelgeuse's recent activity so extraordinary, we need to delve into the concept of a surface mass ejection, SME, and how it differs from the more familiar solar phenomena we observe in our own sun. Our sun regularly undergoes coronal mass ejections, CMEs, during which it expels plasma from its outer atmosphere, typically on the scale of billions of tons of material. These ejections can affect space weather, potentially disrupting satellites, power grids, and communications on Earth. Betelgeuse's surface mass ejection, however, was far more massive and violent than anything we've observed from our sun. According to NASA, the amount of material expelled by Betelgeuse was about 400 billion times more massive than a typical solar CME. This colossal event saw the star ejecting a substantial portion of its outer layers into space, forming a cloud of dust that obscured its light from our viewpoint on Earth, leading to the dramatic dimming observed in late 2019 and early 2020. Astronomers, including those using NASA's Hubble Space Telescope, were able to closely observe the SME and determined the expelled material was responsible for the star's sudden and puzzling decline in brightness. André Dupré, a senior astrophysicist at the Harvard-Smithsonian Center for Astrophysics, led the team that analyzed the event. According to Dupré, Betelgeuse had blown off a huge chunk of its visible surface, a phenomenon unlike anything astronomers had ever witnessed. The SME event disturbed Betelgeuse's regular pulsation cycle, which typically spans around 400 days. The outer layers of the star, which normally pulsate in a predictable rhythm, were thrown into disarray. Dupré described the star's post-SME behavior as being like a bowl of gelatin, with its surface wobbling and pulsing irregularly in the aftermath of the explosion. The surface mass ejection from Betelgeuse has provided astronomers with a rare and valuable opportunity to study stellar evolution in real time. While it is common for red supergiants to lose mass as they near the end of their life cycle, the sheer volume of material expelled by Betelgeuse during this event was unprecedented. This has led scientists to reconsider their models of how stars lose mass and evolve before ultimately exploding as supernovae. One of the key questions arising from this event is whether the SME signals the imminent demise of Betelgeuse. While some initial excitement suggested that the star's dimming could be a precursor to a supernova, NASA scientists have since stated that Betelgeuse is not likely to explode anytime soon. In fact, despite the massive nature of the surface mass ejection, Betelgeuse could continue to burn for thousands, if not tens of thousands, of years before it finally goes supernova. Nevertheless, Betelgeuse remains in a volatile and dynamic state. The star's disrupted pulsation cycle indicates that its outer layers are still in turmoil, and astronomers will continue to monitor it closely for further developments. The SME event may have been a one-time occurrence, or it could be a sign of more mass loss to come as Betelgeuse approaches the final stages of its life. When Betelgeuse does eventually explode, the resulting supernova will be one of the most spectacular astronomical events in human history. Supernovae are extremely rare occurrences in our galaxy. The last supernova visible to the naked eye occurred in 1604, though it was only visible through telescopes. Betelgeuse's proximity to Earth means that when it does explode, it will be a truly remarkable sight. At the time of its supernova, Betelgeuse will become as bright as the full moon, and will be visible even during the daytime for weeks or months. The energy released during the explosion will briefly outshine the entire Milky Way galaxy, and the light from the supernova will continue to illuminate the sky for years as the remnants of the explosion expand and cool. The shock wave from the explosion will travel through space, interacting with nearby stars and potentially triggering new star formation in the surrounding regions. In the aftermath of the supernova, Betelgeuse will leave behind either a neutron star or a black hole, depending on the exact nature of its collapse. The surrounding material ejected by the explosion will form a new nebula, similar to the famous Crab Nebula, which was formed by a supernova observed in 1054. This new nebula will serve as a long-lasting reminder of Betelgeuse's final act, a cosmic testament to the incredible power of supernovae. Betelgeuse's surface mass ejection and the subsequent dimming event have far-reaching implications for our understanding of stellar evolution, particularly in the case of massive stars like red supergiants. The data gathered from this event will help astronomers refine their models of how stars lose mass in the final stages of their life cycles. This, in turn, could shed light on other supergiants and even help scientists predict when other nearby stars might go supernova. Furthermore, Betelgeuse's behavior offers insight into the types of conditions that could lead to sudden and dramatic changes in stars. The unexpected nature of the SME event suggests that there may be many more surprises lurking in the lives of massive stars that we have yet to uncover. As our observational technology improves, with more advanced telescopes and instruments being launched into space, we may witness even more extraordinary events like this in the future. Betelgeuse's surface mass ejection and the dramatic dimming that followed mark a pivotal moment in our understanding of stellar processes. The unprecedented scale of the event has provided astronomers with a rare opportunity to study a massive star in its twilight years, observing in real time the complex and often violent processes that govern the end stages of stellar life. While the much-anticipated Betelgeuse supernova may still be thousands of years away, The recent SME event serves as a reminder of the incredible forces at work in the universe. As we continue to observe Betelgeuse, we may uncover even more mysteries about its future, and about the fates of other stars like it. The cosmic drama unfolding in the constellation of Orion is far from over, and with each new discovery, we come one step closer to understanding the life cycles of the stars that shape our universe.